Alright, so this is my model. The objective of this model is to extract from a classification shapefile the attributes that fit within certain boundaries, and then those attribute tables to export them to an Excel file. The Excel file must have a forest percentage, so a certain type of land cover type percentage, and its total area. So the input data classification, this is where you put the shapefile that has embedded its the all the different types of classification. Now you have this is a parameter which will work when you run the model without trying to go into the editing view. So this is a parameter, and I'm putting here the input data classification. And after that, we need to select the layer by certain attributes. So in this case, we want to only analyze a certain classification type, which in this case is a forest. So forest and this classification code are 300, 311, 312, and 313. So these are all forests. Now the second step is to have the embedded boundaries, which in this case is just all the cities within a county. So this is the shapefile for the county that has embedded all the cities, and we're gonna select the field of the city name. So the column within the attribute table that has the city name. Therefore, the output of this is selected boundaries. So we are selecting each boundary here, each city. And here we are selecting only the forest land types. After that, we're gonna select layer by location of this selected forest land types. We're gonna select only the ones within this selected boundary. This is the second selection item. After that, we're gonna target with the result of this is the target features within the boundary. So all the forests that fit that fall completely within this selected boundary, the city specifically. Now the iteration feature will run every single city many times. So for every different city within the city name field, it will run this whole process. So in this, there's one city that is being processed right now. And this over here, this output is that contains all the forests within that specific selected city. Then we're gonna dissolve it, but the product of that dissolve is another file, which we need to later delete. So the temporary file of the dissolve will pretty much dissolve all the rows into one single row. So we're gonna collapse this 311, 312, and 313, which are codes for land types, and all of them are forests, so we need to collapse them because we want to see the overall forest. So we don't care if it's 311, 312, or 313. So after that, we're dissolving that, and then we're gonna spatial join with the selected boundaries. So after that, because we need a field within that selected boundary, a field that is within the embedded boundary that is called area. So the total area of that city, specific city, will be joined into the attribute table of the land cover classification. So the area that is here in the attribute table in this original table is not here, obviously, in this land type classification. So land cover classification doesn't have the area of the city, obviously. So we need to spatial join both of them in order for the product to have the area. So the product of this is the land cover classification of a specific city. So it will have all the polygons of that forest that fall into that completely within that city. And then it'll have um and in one of the columns it would have the area, total area of that specific city. And after that we need to calculate a field. So we're gonna calculate the field of this we're gonna calculate the field of the forest percentage, because when we dissolve here, all the land forest types are gonna be collapsed into one, and it'll automatically give you the total area of those summed polygons in a field called shape underscore area. So that shape underscore area is pretty much, you can interpret it as a forest, as a selected land type. So after that we have uh we need to calculate the field of forest percentage. So all we need to do is divide the field of shape area, which corresponds to the total forest area within that city, and divide it by the total area of that city and multiply it by 100. So that is this final output. And after that, there's a Python script that you can edit, and also this is the way you edit, or you can also go into view and check the Python, and here you can manage the script and see if it's working or if you can edit it from here. And after that you press right click and save transcript. And to add a transcript you need to go into the catalog pane, then toolboxes, and then right click on the toolbox of this project and create new script. So this script one will grab all the attribute tables from this geodatabase and then merge all the attribute tables, all the contents of each attribute table, into one single Excel file. And this is the end of it. And to validate that it's working, you can also go into view and then catalog pane, and it'll save in this geodatabase, which is also a parameter. So you'll go into databases, the geodatabase that is stored here, and if it's working, it'll contain all the shape files, which is here. So the percentage value percentage is pretty much taking the name of this value, which is the city, selected city within that iteration. So at first it started with almost, which is the selected city here, and it's giving a value. So you can name that specific shapefile with a percentage value percentage.